Lesson 4.11. How can I determine the product? Introduction to factoring expressions. So to go this lesson, we'll review how to build rectangles using tiles, and we'll identify patterns for determining the dimensions of a complete area model. So in the previous lessons, we used area models to multiply two binomial functions, right? We had this, and we multiplied, used the area model to multiply, and we had this as a sum. In this lesson, we're going to try to reverse the process. We're going to go from here to there. And we're going to talk about how do we do that. We'll start with reviewing what we know. So here's the algebra tiles. We're going to break it down to a product and a sum. So first, let's fill this out, right? All these are y, and all these are x length, and these are x length, and these are all 1. Right, so anything that has this length is x. This is x times y. You can see the y here and the x there. X times y gets me xy. So we know these have length of x. When we want to figure out the sides here, this length is the length of y. So for y right there. This length is the length of x. And then we have 1, 1. So I'll put 1, 1. So this would be x plus y plus 2. Going down this side, remember these are all length of 1 here, so this is actually 1, 1, 1, 1, and then it's not y, it's x, right? X is this up, you can see right here. X, it actually would have been easier going down this side, 1, 1, 1, 1, x. So which will make this side x plus 4. Now we're going to write it as a product and sum. Right, the product, this is this side, the length times the width. So x plus 4 times the top, y plus x plus 2. And then the sum is going to be, just find the area of the inside. We have xy, x squared, plus, how many y's do I have? 1, 2, 3, 4, so 4y. Plus the number of x's I have, 1, 2, 3, 4. Ooh, there's 2 more here though. So 6 total, 1, 2, 3, 4, 5, 6. And then plus 8 ones. So this is the area of the sum, and there's the product. And that's kind of the goal today, right? We want to break this down to products. Use the algebra or an area model to multiply this by transfer the sum. So kind of the same idea. Hopefully we know how to do this. If I was going to use my area model, I can draw a rectangle. There we go. So we're going to do 6x minus 1. And over here we'll do 3x plus 2. And remember, what we're going to do here is we're going to multiply these. I'm going to find the area of this rectangle by multiplying these two. Length times width. So 6 times 3 is 18. And x times x is x squared. 3x times negative 1. We want to get this area here. So that'll be negative 3x. Down here, positive 2 times 6 is multiplied to 12x. And then positive 2 times 1 is negative 2. And then we're going to write this as a sum. So we're going to add these up. We can only add these middle two right there. They both have a single x. So we get 18x squared plus 9x minus 2. And again, if I want to write this as a product sum, it's equal this right here. 6x minus 1 times, what if I find 3x plus 2? Again, so we've been going a lot of forward just by getting from these two to get this. Today we're going to try to go backwards. We're going to try to get this answer and go backwards to what it does it break down to. And that process of going backwards, the process to change a sum to a product is called factoring. So when we do this, we call this factoring. We're going to break a sum to a product. So that's factoring. That's kind of the goal today. And so when you write it like this, it's written in factored form. So how are we going to get from this sum to having it written in factored form to a product, breaking it up to factoring it? Well, first we look at algebra tiles. If I could break this down with algebra tiles, and then we could just look at the sides like we did here. So that's the first step. The first one we're going to look at is with using algebra tiles. So 2x squared plus 7x plus 6. I have it broken up here. So 2x squares, there's 7 x's, and there's 6 1s. Remember, the whole goal of algebra is try to make it so you can get a rectangle out of it. use any combination. You can flip anything, but you want to try to make a rectangle. Kind of like this, but I got to use all the values here. And I'll save some time. I'm going to play with it off camera. Okay, quick cut, but here I did most of the work. There's 2x squared. There's still 7 x's right here, and then there's 6 ones. So I made it a rectangle. And there's actually lots of ways to do it. On this paper here, I just gave another example of a rectangle, like this. But if you could break this down into a rectangle using algebra tiles, then we can just do area, which is this guy, equals the product. And we can factor it. So the product here, remember, it's always, when you use this side, this is an x, and these lengths are 1. So this one side here would be x plus 2. And then going down the side here, this length here is an x. That's another x. And then these are 1s. So I have 2x plus 3. And we factored it using algebra tiles. Right? I was able to rewrite this as a rectangle using algebra tiles. And then figure out the sides. x11, xx, 111, 2x plus 3. If I go back to my algebra tiles, it would be the same thing. This would be 2x and x, 2x plus 3, and x plus 1, 1. So no matter how you do it, it works out. Now sometimes you can't factor this. Here's an example of x squared plus 4x is plus 1. And you can see here, I try to do it, and there's no way you can rearrange this to make it work. So when that happens, when you cannot make a rectangle not possible, it cannot be factored. So that's one way to factor it. You could get out your algebra tiles, make a rectangle out of values you have, and then figure out the sides of the rectangle you made. And if you cannot make a rectangle, if it's just not possible, then it's not factorable. So what if we don't have algebra tiles and we just want to do it this way, and do it a separate way? Well, we could kind of reverse engineer a rectangle. So we're going to do 2 examples here real quick. And to do this, we want to factor out the GCS. Factor out the greatest common factor, GCF. So let's look at the numbers 6 and 10. So the factor of the 6 with numbers that multiply to get 6. That would be like 1 and 6 and like 2 and 3. Right, those are all numbers that multiply to get 6. And how about 10? The numbers that multiply to get 10 are like 1 and 10 and 2 and 5. 2 and 5. So the greatest common factor of these two, number-wise, is this 2. That's the biggest thing that factors both of them, is 2. So over here, looking at it this way, 2's the thing I can pull out. They both have a factor of 2. Now let's look at the x's. This has 2 x's, this has 1 x. Pull out 1 x from both of them because this doesn't have 2 x's to pull out. So factor out 2x. And once we have that down, then this part's just to get right. You got to think about it logically. Like, what times 2x gets me 6x squared? Well, 2 times 3 gets me 6, and x times x would give me 3x. Would give me 6x squared. And the same thing over here. 2x times what gets me 10x? Well, 2 times 5 gets me 10. And then it already has the x. So that's it. We factor this one. It is going to be 2x times 3x plus 5. And that is factored. Then we go on to this last one here. Now we have a rectangle. Well, we're going to do the same idea. We're going to try to break it down either this way, or this way, or this way, and this way. You can start off anywhere you want, whichever way is easiest. I'm going to start down here. So I got to find out what's the greatest common factor of 4x and negative 6. So if you're not sure, you can start with 4 and 6. We're going to think that multiply to get 4, 1 and 4, and 2 and 2. Let's try and do a little in order this time. Things that multiply by get 6, we know already. Right from there, it's 1, 2, 3, and 6. And once again, the biggest factor I see is 2. So we pull 2 out here. And I cannot pull anything else out. That's a 4x. This doesn't have an x, so it's only thing I only can factor out to 2. So now that I know what that's a 2, I probably can figure out what these two are. 2 times what gets me 4x, right? 2 times something gets me 4x. That would be 2x, right? 2 times 2 gets me 4. X times 2x times 2 gets me 4x. Then we're going to do the same thing here. 2 times 4 gets me negative 6. That should be negative 3. There we go. And once I have that down, I just got to find this guy. And you can use any one of these you want. What times 2x gets me 2x squared? Or what times negative 3 gets me negative 3x? In both cases, that should be an x. Well, you factored it. This top side is 2x minus 3. And this side right here is x plus 2. So this is 2x minus 3 times x plus 2. Or if you want, you could write it the opposite way. X plus 2 times 2x minus 3. And that's the lesson.